Hi, my name's Melanie, and this is for Lab 13 and 14 of Physics. I did the lab at home and answered everything, but I'm currently at my parents' house, and my little baby, my 4-month-old, has been really sick, so I haven't really, I'm kind of scattered. So I just have the post-lab questions, so that's what I'm going to go over, because that's all I have with me right now. I don't have any of the lab materials, but for Lab 13, the first question was sketch and label what the arrangement of objects and liquids in the beaker are going to be, which I don't have the sketch with me, but the first layer is the corn syrup. That's the bottom layer. The corn syrup is the most dense, and then the middle layer is the water, and then the top layer is the cooking oil. And so on top of the cooking oil was the cork, which floated, and then between the cooking oil and the water is where the coffee lid piece sank to. And then at the very bottom, that's where the washer went to with the cornstarch. Which, by the way, this experiment was super cool because it's like you just had things floating. It was really awesome to look at the density of things. But the second question was rank the liquids and solids in order of least to most dense and use your results to explain your reasoning. As I just explained, density is measured by how tightly the atoms in the substance are packed. So corn syrup was the most dense, water was the middle, and then cooking oil was the least dense. And the experiment showed this with the reasoning, with how things floated depending on the density. The third question was, which of the solid materials used in this experiment would make the best boat and why? And I think the cork would be the best if floating on the cooking oil. And then the coffee lid would be the best if it was on water. And then the washer would be best if it was the cornstarch, except I think it might continue sinking. So I would say probably coffee lid for water. And then number 4 was, would it be easier to design a boat in a world with oceans of maple syrup than oceans of salt water? And my answer is no, because the ocean would be far too dense for anything to sit upright if it had maple syrup instead of salt. So as for Lab 14, the first question is, did the waves seem to go any faster or slower when you tested a variety of amplitude and frequency? And so for me, the more tension with the slinky, the faster the wave would be, and the less tension, the slower. The second question was, what did you notice about the speed of the longitudinal waves compared to the transverse waves? Longitudinal waves were a lot quicker, and this might be because they don't travel side by side like the transverse waves. That's why I think it is. And then the third question was, use data from Table 1 and Table 2 to calculate the average time it took for the wave to travel down and back. Use this time to calculate the average speed for the traveling wave on the slinky for both situations. Fill in Table 4 with your answer. I have the table on my computer, so I can't show you. But basically for trial 1, this is Table 4. The velocity from the stopwatch was 3.001, and this was counting down and back as 4 millimeter. And then velocity from tension and mass density was 1.75. The percent difference was 52. As for trial 2, the velocity from stopwatch was 4.48. The velocity from tension and mass density was 2.04, and the percent difference was 74%. So that is my scattering of what I have for this lab. Thank you so much.